This study compares the TPC-DS benchmark with BERT and Spider to evaluate large language models' performance in generating SQL queries. TPC-DS, known for its complex SQL queries, is found to exhibit a significantly higher level of structural complexity. 11 LLMs were used to generate SQL queries based on TPC-DS, but the findings indicate that current models fall short in generating accurate decision-making queries. A comparison with the TPC-DS gold standard using fuzzy structure matching techniques shows insufficient accuracy for practical applications. The study highlights the limitations of existing benchmarks and emphasizes the need for more complex and realistic benchmarks. It also discusses the challenges in handling complex SQL queries and introduces various models and techniques for text-to-SQL tasks. The TPC-DS benchmark is highlighted for its greater where clause complexity and heavy usage of common table expressions, emphasizing its role in evaluating text-to-SQL model performance. The study's findings and methodologies provide a comprehensive evaluation of model performance and highlight the importance of considering structural complexity in SQL queries. Here is a combined summary of the 4 pages. This research paper presents a comparative analysis of SQL query generation capabilities between various large language models, LLMs, and traditional database query optimization techniques. The study utilizes the TPC-DS workload as a benchmark to evaluate the complexity and efficiency of queries generated by these models. The TPC-DS workload is characterized by its complex queries, featuring a higher number of common table expressions, nested selects, aggregations, joins, and subqueries, as well as a larger set of column references and function calls. 11 different LLMs, including GPT-4, Gemini 1.5, and Mistral Large, are evaluated based on their ability to replicate the features and complexity of the gold standard queries from TPC-DS. The results show that while some models perform better than others, there is still a significant gap between the generated queries and the gold standard queries in terms of complexity and accuracy. The study highlights the need for more sophisticated evaluation metrics that can capture the nuances of query complexity and the challenges posed by real-world workloads. The authors validate the generated queries using a PostgreSQL database, correcting any syntax errors or incorrect schema information. The results indicate that GPT-4, Gemini 1.5, and Mistral Large have the highest success rate in generating queries, while smaller models have a lower success rate. The structural complexity of the generated queries is analyzed by comparing the number of columns and joins, with Gemini 1.5, GPT-4, Mistral, and Llama 370B matching the closest the structural complexity of TPC-DS queries. The study's findings are encouraging, as large LLMs are capable of generating queries that can match the complexity of the TPC-DS workload. However, the authors also plan to evaluate the quality of these queries with respect to the gold queries given by TPC-DS, using bag-valued features as defined in Section 3. The evaluation of large language models, LLMs, for generating queries against the TPC-DS benchmark reveals a significant gap in accuracy. The Jaccard similarity coefficient is used to measure the similarity between generated queries and TPC-DS queries, with none of the LLMs successfully matching the where predicates and join pairs. Radar plots visualize the performance of the top 5 LLMs, demonstrating insufficient accuracy for practical applications. To improve accuracy, incremental SQL generation, fine-tuning smaller models, and ensemble methods are proposed. Additionally, a human-in-the-loop workflow is suggested, recognizing the difficulty of complex SQL generation and the need for user input. The study emphasizes the need for novel approaches to bridge the gap between current state-of-the-art and practical real-world applications.